I was in the middle of college application season, but one of the projects was she was doing a scholarship video and wanted to demonstrate a robot having a navigation failure. So she drove it into a planter box in her backyard several times to illustrate a navigation failure. And we discovered a hornet's nest. And we both got hit a few times. And so anyway, we named it Sting Operation and gave it a mascot after that. So anyway, the point is, eventually this...
Can I introduce Sharp Friend?
Okay, this is Sharp Friend.
Sharp Friend.
Anyway, it's an iPad on a stick, as you can see. But let's see, what do I want to say about it? So eventually, the plan is to get Ross going on the Raspberry Pi and be able to operate this from a college dorm room on the East Coast, so that Shiloh can attend homebrew robotics from the East Coast. We haven't quite got there yet. What we have going is we have both the Raspberry Pi and a Pi board running MicroPython. Mark, have you tracked how many minutes it took me to get into the...
That was about 7.
Okay, before I actually mentioned MicroPython. So anyway, so that's driving the motor controller, and we gave a Nito bot vac a lidarectomy, and so that's spinning. Although that isn't, other than spinning, it's not. We're not feeding the data into Ross yet. That's kind of the next step, and so it has remote operate. Now we can teleop it with radio control, and eventually get to teleop from software. What else do you want to say about it? You don't know?
You could mention the googly eyes on the LiDAR.
The googly eyes on the LiDAR, okay.
Important.
That's important. Oh, and one of the things I do want to talk about is later on when we get to lightning talks, I'm going to be talking a little bit about how we're actually feeding the radio control signal from this into the microcontroller, and how you can get all 8 channels out of an RC transmitter with one GPIO pin, which is an ancient trick. It's about as old as dirt, but I found a lot of people don't actually know the trick, and it's probably because I'm old as dirt, and that's why I remember it. Anyway, so what else do you want to say about it? So we aren't actually doing telepresence tonight, but
it's John and John's bass.
John and John made the bass, yes, and
John Erickson and John Carlini.
That's right, John. Yes, and
I'll build you one of those if you like.
Yeah. Okay. So yes, and we have a mode indicator that is wired in parallel with the RC. So anyway, anything else? Well, I guess we're done. Okay, who's next?
You probably know Loco-Mo, the smart table. It's a table designed to get from one place to another and back again in an unstructured environment. I'm looking for my smartphone. It's in my pocket. Don't panic. Don't panic. Okay. So here you can see my robot has a Skype account, and I use that for telepresence. Velcro it right there. I've created this map using ROS, Robot Operating System. It's a robotics framework that gives you a standardized means of messaging, publish and subscribe, a standardized way of mapping with G-mapping, a standardized way of navigating with MoveBase and AMCL, Adaptive Monte Carlo Localization, and standardized means of logging with ROS-BAG, and standardized means of distribution through GitHub. So it's got all this great stuff. So I've created this map, and I'm going to have Loco-Mo come in front of the podium here, autonomously, navigating, and then we'll go on with the rest of the presentation, which is my machine intelligence presentation. So you folks don't get if you don't get a presenter, and if not enough folks show up for the challenge, this is what you get. Okay? Why isn't that way?
We love you, Camp.
Thank you, thank you. Appreciate that. Let's see here. This is one of my favorite ROS commands. It's
reboot.
No, that's one.
Windows command.
But it's, let's see here. Oh, here it comes. Ross service call, move base, clear cost maps. My ultrasonics create a lot of noise, and it sometimes hems the robot in. Oh, come on, Mo. There you are. He's a little shy this evening. So here he is navigating. I could do a Danny Watson. Dun, 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 dun,
So,
dun.
At the base, you have a flickering LED
Well, that's
module.
Oh, here, that's ultrasonics.
Okay.
Glad you asked. The HPRC SIG Special Interest Group meets the penultimate Wednesday at the tech shop in Redwood City. And our special interest has become ROS, Robot Operating System. And a lot of what we do with it is built on the NITO BotVac, which, full disclosure here, I do work at NITO. I am the technician at NITO. And so the great thing about the BotVac is it's as good a trainer as the TurtleBot. And it'll clean your floor. Okay, so the deal here is that it has an API so you can drive the wheels around and you read the LiDAR scans. The LiDAR spins at 5 hertz, takes 360 snapshots per revolution, and that way you get a bird's eye view from 4 inches high. That's how I created this map with RViz. That's ROS Visualizer, and it's three-dimensional also. So it's like you can set it like that, and you can zoom in and here,
Up on the screen.
because that's too complicated, and I haven't even got to the regular part of the presentation yet. But anyways, this is RViz and ROS Visualizer, and it's one of those things that ROS lets you plug into. I would never write a mapping routine. I would never write a navigation routine. But I could take the code that was written for the PR2. I got a little time here, right? You guys know about the PR2? Okay. ROS was developed for PR2, Personal Robot 2. Tony here had a lot to do with that, and there's other folks here that involved. But PR2's claim to fame are it could plug itself in. It's important for a free-range robot. It could actually, the holy grail of robotics, fetch a beer from the refrigerator. Oh yeah, open the door and bring the beer to you. And it could actually fold clothes. Now, it'd take it 20 minutes to fold a t-shirt, but you put it in a room with a stack of clothes, and at the end of the day, all your clothes are folded. That's $250,000, and the software developed for it, ROS, scales. So you change your wheel diameter, your track width, and software developed for a $250,000 robot runs on your $400 vacuum cleaner. And again, that plugs into all this great stuff for mapping. I've got another, the iteration we work on at SV ROS is basically this BotVac package on a Raspberry Pi that fits in the dirt bin. Okay, here with the smart table, I have another 3 foot of height I have to deal with. So what I'm using is the ROS serial connected to the ultrasonics, and I use that in navigation so the robot doesn't try to go under the coffee table. All right.
You mentioned the meetup at
Yeah, it's the HBRC SIG Special Interest Group. We piggyback off of SV ROS meetup, and Alan Fetterman actually heads that. And we meet at the tech shop in Redwood City. Join the mailing list.
Okay.
That's where all the information comes out.
On the left panel of the website, you'll find a link to these meetings that Camp is discussing.
Thank you.
Thank you. And so here, you know, I drive around first, I make this map, then you save the map, and then you load in the navigation stack. Be sure you save the map before you load in the navigation, before you kill the G-mapping routine, okay? I'm just saying. And so, but then that makes a map, and then you're navigating within the map. And I've got the video in here, and obviously I've Velcroed a smartphone in here. I could use it for telepresence.